Good morning, everybody. My name is George Stanchev. I'm a CEO of Erglon. It's a Bulgarian company. We're in thermal imaging since 2009. We're behind US brands like Nevisys, Armacite. We've been 2 years with FLIR by developing the boson with them, transitioning from tau to boson. Then we support some other very important brands in the US, mainly in the US space. And today, we're going to talk about tactical dominance. We'll start with thermals. We'll talk about AI, enhanced imaging. We'll talk about multi-spectrum imaging based on thermal, how we're going to penetrate these spectrums, and how we're going to really make this camera to take a decision for us. There's a 4-step process into a current imaging. It's detection, identification, decision, and action. Currently, the thermal imaging does only the first one, detection. Is the thermal imaging good enough to stay with that detection, or we have to be completely intelligent? And we're going to see why. Going through this presentation, it's very important. We'll start with operational reality. Because before we talk about technology, operational reality matters because technology needs to reflect the operational reality. And nowadays, the operational reality evolved. It drastically changed. We have darkness, smoke, fog, dust, urban clutter, and this is just the visibility, just one small portion of this operational reality. Darkness is just the baseline, and that's usually where we start. Nothing major happens during the day. So darkness, we add to it the smoke, we add fog, we add dust and urban clutter, and then what is the thermal good enough to go and detect the object? Is it good enough to identify the object? Is it good enough to give you the right decision? Then the operational reality demands faster engagements and shorter decisions. Faster engagements, if you are not acting fast, if you leave your brain to take a decision, then you're easy target. So these systems now evolving further, they need to be able to help you on basic tactical decisions. Operator cognitive overload. Imagine a dismounted soldier. It has multiple sensors, visual, thermal, I-square. It has multiple comms, navigation. It has multiple threats coming in all the time. So all this thing is a cognitive overload. He needs to filter that and decide where and how to act very quickly. And then multi-domain threats. Now, as we see, the warfare is completely different with what it was like even 10 years ago. We have drones in the air, we have terrestrial also unmanned vehicle, we have urban clutter, we have a lot of things happening at the same time. And an intelligent system, it can really select the priorities of those and let you target the highest priority first. So the bottom line of this is that the reality changed a lot. There are very little human decisions made on the field. It's all going to be artificial intelligence and sensors. This needs to be handled properly, and proper information needs to be delivered to the dismounted unit. Before we talk about innovation, let's talk about what it was like 20 years ago. Thermal imaging evolved in the last 10 years a lot, but really was known for over 20. But what was known 20 years ago? There were large optics that had the sensor only delivering data stream. Then you're supposed to have an FPGA processing it. Then you have to have overlay and another chip. So it was very large system. You can see this is one of the first systems I built in 2009. So that's literally FPGA-based system. Now we can see still some systems like that on the market, but are they useful? Are they combat ready? So standalone systems, we usually like mention that a dismounted soldier can have I-square, SWIR, long-wave infrared cameras, and they are all standalone. So imagine that what it's going to be for the soldier to decide which one to use at what condition. Now systems improving from standalone to unified. And this is what we're going to talk in the next slides too. So human-only interpretation. Okay, again, you have I-square system that you can drive with, you have thermal system that you can scout with, you can have like an optic system to zoom and identify things, but they're not working all the time, and your brain is the interpretation. So from the detection, identification, decision, and action, you do all the three. Only the first one is the sensors helping you. Then, delayed decision making, that's critical because now milliseconds matter. And that's what we have to be able to prepare with the new systems. And detection without context. So, that's also very important because thermal is thermal. It shows you temperature differences. So you have to detect threat with confidence, not a false confidence. So that's also part of what we're going to talk next. And before talking about intelligence, we're going to talk about how the size matters. So again, we started, that was tau 20 years ago, and on the right side is one of our cores, 20 by 20 millimeters. We see on the bottom right how the sensors evolved. We have the 12, like let's say the green is a 17 micron sensor. That was over here in this one. And that was a VGA size, 640. Then it shifted to the 12 micron. And that's the right shift. The VGA shifted from here to there. So smaller size, higher resolution, higher identification. It immediately helps you. And then now, this year we're introducing the 8.5 microns, which, this is an XGA. XGA from here to there, it's twice less. It's the same size, you get an XGA detection, which makes the system very compact, very light, very low power, everything all together. So it increases your identification range because now, let's say your zoom does not collapse anymore. On 320, if you do 2x zoom, it's already so-so. 4x zoom, you cannot recognize anything. With 1280, about 8 to 16 zoom is where you struggle with 320. So zoom is better. More pixels, you can identify faces. You can identify threats. You can feed to AI to figure out shapes and movement, everything else. So same footprint, higher intelligence. That's what we see now, 20 years later. So from 320, 640, 1280, that's where we're gonna see more, actually 1440 next year. So resolution goes up, form factor keeps the same. And this is the breakthrough in the thermal vision, because usually people were very skeptical in the beginning. We need a large sensor, thermal is slow, we need more exposure. Now technology allows it. This is the most important baseline into building intelligent systems. What it wasn't available 20 years ago was this. Fully integrated SoCs that have CPU subsystem, as you see over here, 4 2 GHz processors, 5 tops, AI subsystem with 2 DSPs inside, 4 tops. Then we have a full ISP, which is a hardware block, thermal and near IR, like a visible ISP. You can fuse multiple cameras into this ISP, into the ISP, not even like now fusion happens on the stream side. That's a waste. Milliseconds count. So you can fuse over here into the ISP. Then is the video subsystem. You have all the codecs there. You can literally have quarter VGA and you have full HD on the display. Then you have the security subsystem. You want to have a secured VPN, drone application or anything else that requires network, here you go. You have certificate in one, certificate on the other side, and a lot of encryption ready to go, hardware level encryption. Even inside the memory, readout is encrypted. All standard interfaces, all standard interfaces that makes that system very flexible for agnostic deployment. So in general, you use that for a thermal scope for dismount soldier, or then convert it to a drone. If you already have the Mavlink interface, the drone talks immediately to it and displays all the graphic on the screen. Power, that's another big thing. FPGAs are very power hungry. I have 20 minutes, that's why I'm looking at my watch all the time. I have a lot to tell, but we'll leave it to the questions at the end. We'll go fast through the slides. So for dismounted units, power is a very key component, is a constraint. And in a purpose, I named this slide Power is a Weapon, because I look at two things. One sensor needs to have a quality and needs to have low power. Otherwise, everything, the mission is in a gamble. So dismounted units instead bringing like battery loaded systems, they can work with very simple systems, and I will explain how we do that. Same thing for UAVs, same things for surveillance. Even the surveillance nodes like border towers and surveillance towers, they have power. It's usually solar power or it's power line power. It's still limited. You have to be sure that you are tapped to the right power and you have continuous operation, and your power doesn't change much, because you crazy things like this. At 20C, you have, let's say, at 5 milliampere hour, which is a typical load for a system, you have 2 hours life on a single 1, 2, 3 battery. Over here at minus 20, it's already to less than an hour, maybe 45 minutes, maybe half an hour. Depends of your design of the system. And that's where we have to talk about smart power. Smart power can, the most power you lose on memory access. Memory access, this is when you process the frames. So in order to process the frames with less power, you optimize the readout. You mostly, if you have a dynamic target, you switch on full frame rate. And frame rate can be anywhere, depends on which system you use, up to like 240 frames per second. From pixels to intelligence. So what is giving you the thermal camera? Thermal camera gives you a thermal footprint. And this is a blob. Really, you don't really know what it is unless your brain says, okay, that's a human, or that's a vehicle, or that's metal which is heated to a point that has some signature. And it's important, these pixels, to turn to an intelligence. How we turn this to intelligence? We, of course, use artificial intelligence to figure out what it is and what it is doing. So faster threat recognition is very important when you get the pixels to be able to identify them. Identification usually happens in the human head. That identification needs to happen into the system, because then you can think about other threats around. So how to work in the United environment, and it should not be cloud dependent. We're going to talk about that, what happens if it's cloud dependent, but in general, we try to bring everything into the unit itself. Self-sustained decision-making unit with all the sensors necessary. So edge AI versus cloud AI. So we have, okay, cloud AI, we know, it's very powerful. It does everything that we need to do. but it has latency and connectivity dependence. So even I think the standard NATO AI was cloudy from Palantir, so that is cloud dependent. You have multiple streams, they come into the center, and the center decides what to do with them. And then what happens with the 4 points of detection, identification, decision, and action? Then you add 2 more. Transmit back, like detection, transmit back identification, which can happen in the AI. Then you have to release the command, and then the action follows. Instead 4, they become 6, and that is too long in many cases. That's why we try to turn the same intelligence within real time, offline capable with base AI platform. But at the end, the bottom line is the tactical outcome we look for is AI use cloud to support and edge AI to survive. So in general, you still need, here's another big topic, because how are we going to leave a machine to take a decision by itself? And already precedents happen in the field like that. Even in the mission that happened in Venezuela, the AI took a decision against the people that sent him the commands. So that is how we train these AIs to execute when they are not controlled by an operator. So AI in thermal imaging, it's in general, as I mentioned, we try to skip these steps. We give detection, identification, decision. Literally at the decision level, we need to get the unit to give you the priority of the decisions. So it can identify person now easily by following patterns, cars, and then based on motion, prioritization, it can decide, is this moving, is it hot, is it not hot, in what direction it is moving, is the recognition, what classification the recognition is, high priority or low priority. Then context-aware alerts. This person can walk at 2 p.m., doesn't matter. But if this person works, let's say, walks at 2 a.m. in a restricted area, then this is flagged. Okay. I started late, but I'll do quick. So that's the interesting part of the presentation. What thermal is, like over here there are 3 images. We have thermal, we have visual, and we have fused. This is with one of our fusion systems, the dual fusion. Thermal gives you a picture of environment. But is this the full picture? It's not the full picture, because with thermal you have issues at dusk and dawn, because the environment is the same temperature, it has issue with rainy environment. That is solved by the visual light. Visual light gives you the detail. When you merge it, then you have the full story over here. And we're after the full story, because the video picture is not, also has weakness into night time. So we can fuse and we can get low, like environmental ambiguity. So this is another example. This is my cat just posing here on thermal, on SWIR, on visual light and fuse. So what we're gonna see here, it's we use low light thermal for detection, because nothing else. It pops up. Everything that breathes, moves, and can be of a target, we see right away. Then SWIR penetrates, see more things that are not available here. And this gives us like penetration through smoke and everything else, much easier to see hidden objects. And then visual. That visual is good during the day, but if I took this picture in the night, you won't see anything. And when you merge all these 3, then you have the full story. And we're after the full story, because this full story we can identify and we can give you the right decision. This is another example. So this is how do you do fusions. You can do by pixel alignment or by object alignment. This is thermal, this is NIR, which you see the people over here. And when you fuse them with edge detect, they look like that, or if you fuse them pixel to pixel, you look like that. But it's not about pixel to pixel. Again, this is an old technology now. It's object recognition, and it's based on AI. There are a lot of capabilities in AI in fusion. I've been doing AI since 2011, and it's very difficult to do it on pixel by pixel because your optics getting very expensive. Yes, I'm finishing. Everything applies to tactical. And of course, everything is encrypted. I show how it is encrypted into the SoC and needs to be updated on a fly. And strategic takeaway is that people doesn't need any more system that detect. They need system that decide. And decision is very important because it offloads the operational load from whoever the operator is, dismounted soldier or operator in the room. So that's pretty much it. Was short, but hopefully I was able to show you the importance of what we're doing now, because the thermals that you can see out there, especially things that are coming offshore, they're still like 20 years ago. And we have to make fully intelligent systems in order to win the battlefield. And there are only 3 countries who know how to survive on the battlefield right now. We have to bring that intelligence here. Thank you, guys. If you have questions.